This is Earth, 335 million years ago. I wasn't around then, but there's just one supercontinent, Pangea. See? Let's watch it shift around and fast forward. Okay, here we go. It just split into two huge pieces. Australia goes this way, North and South America go that way. Africa, Asia, Europe, forming, and there we go. The planet as it is today. Let's keep going. I mean, the continents are always on the move. Over time, some of them will crash into each other. Others will break apart. But that'll take about 100 million years. Better put it on super fast forward. 100 years from now, humans keep spitting carbon dioxide into the atmosphere, and the planet's already warmed up a bunch. The world's ocean levels have risen about 4 feet. The Bahamas? They've totally disappeared. 200 years from now, the Earth's population is about 19 billion people. The climate's gotten even warmer. We're packed in like sardines over here. New medical tech makes it possible to live to 180. But why? Fossil fuel reserves of oil and gas? Long gone. Oh, and the continents have drifted over 16 feet. The Voyager 1 space probe's about to enter an asteroid cloud at the edge of the solar system. It's the most distant man-made object in the universe, I guess. 1,000 years from now, thanks to better quality food, humans are now 7 feet tall on average. Technology solved the pollution and fuel shortage problem. Humanity's doing just fine. Robots do all the work, we just play around all day. Ocean levels have crept up another 10 feet. Islands like the Seychelles, Maldives, Galapagos, and many others have gone underwater. Denmark, the Netherlands, Eastern England, Thailand, and Vietnam are only partially underwater. There's been a huge human migration these last 100 years. Fast forward about 5,000 more years, and it's the year 8113. Humanity's getting ready to open the Crypt of Civilization. It's a hermetically sealed room in Georgia, in the States. Bad Georgia. It was created in 1940, and it's full of about 800 books on microfilm, recordings of famous people's voices. It's also filled with bits of technology from that time, like a toaster, a radio, and a typewriter. Some awesome people created the Crypt of Civilization in case humans experienced a major catastrophe in the distant future and had to rebuild civilization from scratch. We'd all go back to using typewriters. 15,000 years from now, our planet has changed its tilt, and the Sahara Desert is now a tropical paradise. Years of rain turn the dry desert into a wild jungle. 30,000 years from now, the Voyager 1 space probe has finally left the asteroid cloud at the edge of our solar system. If it doesn't collide with anything, it'll be flying in the dark, wide-open outer space for a very long time. 50,000 years from now, the climate's changing a lot. The temperature on Earth is beginning to drop, and we are approaching the beginning of a new ice age. The radio signal with a special "Hello, all you aliens out there" message sent into space in 1974 has reached its destination. The message contained the human number system and data about our DNA and our solar system. If there was someone on the other end to receive this signal, we might have a response from them. 100,000 years from now, one of the largest known stars in our galaxy, Canis Majoris, explodes with enormous force. The explosion of this supernova can be seen from Earth, even during the day, and the nights are much brighter because of the new strong glow in the night sky. What's new on Earth? Supervolcanoes start erupting all over. These volcanoes spew colossal amounts of lava and ash everywhere. Thick black clouds cover most of the sky. This prevents the sun's rays from reaching the ground, and the temperature on our planet drops even lower. Humans mostly live underground anyway, so it's no big deal. Because the stars are gradually moving in different directions, the usual constellations are starting to change shape. Soon, we'll need to come up with totally new constellation names. 250 years from now. Oh, a new island's on the map. Back in 2021, it was just an underwater volcano somewhere in the Pacific. After thousands of years of spouting out lava, it finally reached the ocean surface and busted out in the cool, fresh air. Not much growing on it yet. Niagara Falls has long since disappeared, and Lake Erie and Lake Ontario have teamed up to form one huge superlake. 300,000 years from now, the triple star system WR104 is about to explode. It's spinning crazy fast, and there's a chance that radiation from the explosion could eventually reach Earth. That would do a lot of damage to all life on our planet. Voyager 1 reaches the brightest star in the night sky, Sirius. Not a very funny star at all, it's really Sirius. It's 8.6 light-years from Earth. 500,000 years from now, scientists are pretty sure that a huge meteorite could fall to Earth any day now. It might be even the size of 8 football fields. The impact of such a massive meteorite would cause an explosion so powerful that its sound would be heard on every continent. That would be followed by super strong earthquakes and tsunamis higher than the Brightside Empire municipal building tower thingy. Okay, I just made that up, but who knows what we'll be building in the future. 1 million years from now, the rogue star Gliese 710 comes very close to our solar system. We're surrounded by a huge shield of asteroids called the Oort cloud, and the rogue star is beginning to affect the asteroids hanging out in there. It grabs them, spins them around, and throws them toward the center of our solar system. Comets start to fall on our planet all the time, big ones, causing more tsunamis and earthquakes. 10 million years from now, the Red Sea is gradually expanding into the East African Rift. Africa is now divided in two by a new oceanic gulf. The human DNA molecule has completely decomposed. But it's no big deal. We've become totally digital, without any pesky aging problems. The really cool thing is that other animals have evolved a lot and changed ridiculously. Thanks to a simple interface, we're actually able to talk to dolphins, chimps, dogs, and cats. Turns out cats aren't grumpy, they're just busy contemplating life. 25 million years from now. The San Andreas Fault has been crazy recently and has caused the Gulf of California to flood the Central Valley. There's a new sea on the west coast of North America. 50 million years from now, Africa just collided with Eurasia. The Mediterranean Sea is totally gone. There's a new tallest mountain in the world. Its name? Mount Everest, of course. Australia is continuing its journey north. It already collided with Southeast Asia a few million years ago. The few human colonies still left on Mars need to do some serious packing. Phobos, one of Mars' moons, is beginning to orbit at a lower and lower altitude. That's not good. It's about 14 miles wide, so that's going to be unpleasant. 60 million years from now, the Canadian Rocky Mountains have completely eroded. It's just one gigantic flat plain. 80 million years from now, all that remains of Hawaii is one island. All the others have long since gone underwater. But just next door, a whole new chain of Hawaiian islands has emerged. Finally, 100 million years from now, we made it! The Atlantic shrinking down to nothing. The Americas are almost rubbing up against Africa. Africa's already merged with Eurasia. We've got ourselves a supercontinent again. Hello, Pangea Proxima. All traces of human life are gone or buried deep underground. The movement of the continents has destroyed tunnels, roads, buildings, bridges. Animals and plants now reign supreme on Earth. So, where are all the humans? Well, remember we made the jump to digital about 90 million years ago? Things are still going strong. There are trillions of human minds living on a huge hard drive on a spaceship orbiting Earth. The super low space temperature is good for keeping the drive nice and cool. We have millions of different societies, languages, and cultures, just like we had 100 million years ago. The only difference? We're all little ones and zeros in a huge digital universe that we created. And yes, there's still football.
It seems that humanity has gone a long way since the first people appeared on Earth. We've invented so much cool stuff and developed new technologies. We've risen above other species after having built an advanced civilization. We've come from living in caves and cooking our food on fire to walking on the moon and creating 3D breakfasts. Does it mean we can be considered a Type 5 civilization? Oh, I see you're confused. let me tell you about these civilization types and what they mean. The Type 1 title is given to species that have managed to harness all the available energy of their home planet. That's why this civilization is called a planetary civilization. They gather and store this energy to satisfy the demands of a growing population. We would need to boost our current energy production more than 100,000 times to get to this stage. And then we would be able to get control over all natural forces on the planet, like volcanoes, storms, or earthquakes. It's hard to believe, but it's actually a very basic level. You'll see it later. As for now, let's move to a Type 2 civilization. It can use and store energy at the scale of a star system. That's why this type is often called a stellar civilization. Experts have suggested several potential ways to do it. The most popular one is called the Dyson Sphere. This hypothetical device could encompass every single inch of a star, gathering its energy and transferring it to the planet. What would so much energy mean for the Type 2? First of all, nothing we know about could wipe out such a developed civilization. Let's say a moon-sized object entered our solar system and was heading towards Earth. No need to panic. We would be able to vaporize it as soon as we noticed it. Or maybe we'd just move our planet out of harm's way. Now, a Type 3 civilization can control energy at the immense scale of the entire host galaxy. That's the reason it's called a galactic civilization. The inhabitants of such a civilization would probably be totally different from the human race. They could be cyborgs, both biological and robotic beings. Maybe there would be colonies of robots capable of self-replication. They would spread across the galaxy, colonizing star systems. And still, these species would be restrained by the laws of physics, unless they figured out how to travel at the speed of light. At first, the scale describing civilization types didn't go beyond Type 3, but later, it was extended, and that's how Types 4 and 5 appeared. A Type 4 civilization knows how to harness energy at the scale of the universe it lives in. This could probably allow its inhabitants to live inside supermassive black holes. In any case, they would need to tap into energy sources we can't even imagine at the moment, using currently unknown laws of physics. And finally, an incredibly advanced Type 5 civilization might be living somewhere out there. If we reached this level, we would be able to manipulate energy both within our universe and other universes. Of course, at the moment, we're a very long way from achieving a Type 5 civilization, but it's not impossible. Assuming our world remains intact, we might continue advancing with every next generation. Then, a day may come when we'd be able to travel anywhere we want in the multiverse. Maybe we'd even use wormholes. Theoretical bridges using space-time that creates shortcuts, reducing travel distance and time. We'd be able to tap into mysterious dark matter to produce energy. And we would find the answers to tons of mysteries about us and the universe. But guess what? At the moment, we're not even a Type 1 civilization. Yep, we're not even on the scale yet. Duh! First of all, we're facing some physical limitations of each type of energy source. Plus, we'd need to balance them not to trigger even more climate changes and not make pollution levels rise. Scientists researching this question have concluded that humanity could potentially reach the level of Type 1. But it wouldn't happen until at least 2371.
We have found out quite a lot of things about the past of our planet, but can we figure out its future? And I mean, not guess or predict, but estimate scientifically. Before we move on to assessing the future of our planet, I suggest we define the future of our channel. Please support our work by subscribing and liking. Thank you. Well, experts think we might learn more about the future of Earth with the help of a few long-term factors. Among them, we've got the rate at which the interior of our planet is cooling, the chemistry at Earth's surface, and even the way our planet gravitationally interacts with other objects in the solar system. And don't forget that we humans also cause serious changes to our home planet. For example, take climate engineering and other technologies. Some people even believe that technology might be what will lead humanity to extinction. If it ever happens, the planet will begin to evolve naturally and much more slowly. Experts think that over periods of hundreds of millions of years, certain space invaders can lead to mass extinctions on Earth. I mean, comets and asteroids that might crash into our beautiful blue world at one point in the future. Another threat from space can be a powerful near-Earth supernova. It is a gigantic explosion, the largest in space, and it unleashes enormous amounts of energy. The temperature at the core of a supernova is often 6,000 times higher than that in the Sun's core. It can reach several billion degrees F within microseconds. After that, atoms get crammed together so infinitely close that the squeezed core recoils and the star explodes, creating a superheated shock wave. If a supernova ever occurred around 30 light-years away from Earth, we'd have huge problems. An incredibly powerful blast of radiation would bring a massive influx of high-energy neutrinos. Our planet would be vaporized in just a fraction of a second. Even the shock wave would have enough force to wipe out our oceans and the entire atmosphere of our planet. Another prediction says that while the Sun is orbiting the Milky Way, stray stars may approach our solar system. They can get close enough to have a disastrous influence on our planet. Such an encounter can also lead to comets in the Oort clouds becoming more active. The Oort cloud is a region of space filled with icy celestial bodies orbiting within half a light-year away from the Sun. And if something, for example, a wandering star destabilizes this region, the number of comets reaching the inner solar system and US will likely increase 40-fold. But while scientists can't be sure about asteroid impacts or supernova explosions, they can forecast large-scale geological events. One theory claims that Earth will continue to experience glacial periods for quite some time. Also, the movement of tectonic plates will probably result in the appearance of a new supercontinent. It might happen in 250, 300 million years from now. The changes in the luminosity of the Sun, which will become brighter and brighter, will lead to an increased level of solar radiation reaching Earth. It will eventually cause a drop in the level of carbon dioxide in the atmosphere around 600 million years from now. If this tendency continues, plant life will disappear from the face of the Earth. Of course, it will also influence animal life, since plants are the base of the animal food chain on our planet. In 10 billion years or so, the luminosity of the Sun will become 10% higher than it is now. It will turn the atmosphere of the planet into a moist greenhouse. The oceans will start to evaporate. In around 2-3 billion years, the planet's magnetic field might stop functioning. 4 billion years from now, a rise in Earth's surface temperature will lead to conditions resembling present-day Venus. By that point, there won't be any life left on the planet. And finally, the Sun will most probably absorb Earth in around 7.5 billion years. It will happen after our star enters its red giant phase and expands way beyond the current orbit of our planet.
Imagine traveling 10,000 years into the future. What would our planet look like? Would there be giant volcanoes? Would most of its surface be covered with oceans? And what if we traveled even farther, 1 billion years in the future? Now, Earth is about 4.5 billion years old, and when it formed, it looked very different from now. It was an extremely hot world, drowning in molten magma. Then, over the course of a few hundred million years, the planet began to cool. That's when the oceans filled with liquid water appeared on its surface. Heavy elements, initially floating on the surface of this bizarre Earth, started sinking past the oceans and magma toward the center of the planet. Earth became layered. The outermost layer was a solid covering made out of relatively light material, while the denser substances sank to the center of the planet. That's how it all began. Now, speaking about such a distant future, and 1 billion years is no joke, the chances that humans will still be around are very slim. You see, there are quite a lot of threats the human race might face in the process of its development. Climate change, overpopulation, falling asteroids and comets, ice ages, the sun getting hotter. Let's say you've got your hands on a time machine, and on your way to see what our planet will look like in 1 billion of years, you make a few stops. And the first one is 10,000 years into the future. One of the main changes is the appearance of people. Apparently, genetic differences are no longer regional. Such traits as skin tone or hair and eye color are evenly distributed around the globe. 20,000 into the future, and you don't understand people anymore. None of the current languages is recognizable, and the language people speak only has 1% of the present-day vocabulary. Moving further, 50,000 years into the future, and you realize with horror that a new ice age has started. Niagara Falls have eroded, and a day on Earth has increased by 1 second. Your next stop is 250,000 years from now. The landscape of the planet has changed a bit. For example, a new island has formed in Hawaii. After exiting your time machine 500,000 years into the future, you realize you might have made a mistake. Fires are raging all over the planet and the air is nearly unbreathable. The reason is a giant asteroid. People didn't manage to prevent it from hitting Earth. You hop into your time machine and set the timer to 1 million years from now. It seems you're out of luck. This time, it's a massive supervolcano eruption, spewing out hundreds of cubic miles of ash. It's already produced enough lava to fill 75% of the Grand Canyon. 2 million years into the future, and people have created settlements all over the solar system. Humans look different on different planets and moons since their bodies have adapted to particular conditions existing in those regions. 50 million years into the future, and you see that Earth is still changing. A massive part of Eastern Africa has broken off, forming a new ocean basin. Africa has crashed into Eurasia and closed off the Mediterranean Sea. A new mountain range, higher than Mount Everest, has formed between these two landmasses. Also, Mars has collided with its moon and got a cool ring system, just like Saturn. You make a stop 600 million years into the future and find out that a gamma-ray burst has occurred around 6,500 light-years away from Earth. Luckily, it hasn't hit our planet. Otherwise, there would no longer be the protective ozone layer and it would have caused a mass extinction. Also, the moon is now so far from Earth that there are no more total solar eclipses. And now, your final destination, Earth 1 billion years from now. With bated breath, you leave your time machine and freeze in shock. Our once beautiful planet has turned into a lifeless desert. The levels of carbon dioxide have dropped dramatically, and there's no photosynthesis anymore. It means that free oxygen and ozone have disappeared from the atmosphere, and there's no more complex life on the planet. Plus, the sun's luminosity has increased by 10%, making average temperatures on Earth rise at least twice. You feel as if you're standing in a giant damp greenhouse. The oceans have evaporated, leaving a few small pockets of water at the poles. What about people? You won't find them on Earth. By now, they have already colonized some faraway planets and faraway galaxies. You should probably leave this inhospitable world too.
Mercury. Mercury formed when gravity pulled together swirling gas and dust to form a small planet closest to the Sun. The planet changed its appearance as asteroids and comets crashed into its surface, just like our moon. Venus. The planet could have had a perfectly habitable environment for 2 to 3 billion years after the planet formed, suggesting that life had plenty of time to originate there. However, the resurfacing event triggered a series of incidents that caused a release, or outgassing, of carbon dioxide stored in the rocks of the planet. As a result, Venus's atmosphere became too dense and hot for life to survive. Earth. The planet was initially very hot, and the heavy iron sank to the center, while the lighter silicates rose to the surface. The entire process of planet formation took about 20 million years to complete. Mars. Mars probably had a dense atmosphere that kept the planet warm enough for water to flow over the surface. Liquid water could probably have existed on both Venus and Mars at the same time. Jupiter. Looked about the same, only farther from the Sun. It was one of the first planets in the solar system. Jupiter took on most of the mass left after the Sun was formed. Jupiter's composition is similar to that of the Sun. Saturn. Most likely did not originally have rings. Like Jupiter, Saturn is composed mostly of hydrogen and helium, the same two basic components that make up the Sun. The only planet in our solar system with an average density less than water. Uranus. Uranus probably formed closer to the Sun and moved to the outer part of the solar system about 4 billion years ago. Most, 80% or more, of the planet's mass is made up of a hot, dense liquid of icy materials, water, methane, and ammonia. The planet has always looked like this. Neptune. Probably formed closer to the Sun. There may be an ocean of very hot water beneath Neptune's cold clouds. It doesn't boil away because the incredibly high pressure keeps it inside. Neptune is the windiest world in our solar system. Despite its great distance and low energy input from the Sun, winds on Neptune can be 3 times stronger than on Jupiter and 9 times stronger than on Earth. The appearance of the planet is affected by the appearance and disappearance of hurricanes. Sun. According to scientific research, the Sun was about 30% dimmer when the Earth formed 4.5 billion years ago. Over time, it has shone more and more brilliantly due to the nuclear fusion process that takes place roughly 5 billion years from now. The original faint Sun should have led to disaster here on Earth, but a thicker atmosphere on the early Earth might have been able to trap more heat, keeping the planet warm enough to support liquid water.
The Big Bang Theory doesn't explain how exactly our cosmos started. It's more like a story about what happened after, in the earliest stages of the universe. That's when all stars, galaxies, and specks of dust were crammed into a dot, no bigger than a peach with a temperature of more than 1 trillion degrees. Our cosmos doesn't have an edge or outside. The Big Bang wasn't an explosion that happened at some particular point. It was the moment when space itself began to expand everywhere at the same time. That's a process we call inflation. When the cosmos was nearly 1 million times smaller than today, everything was just a plasma that later expanded, cooled, and then converted into a neutral gas. That was the time when the first atoms formed. All these processes released enormous amounts of radiation. The cosmic microwave background, CMB, is the fossil of that radiation that dates back to about 380,000 years after the Big Bang. Before that, the heat from the creation of the universe was way too intense for even light to shine. Only after matter cooled down did it get lighter because the universe became less dense and more transparent. In the first 3 minutes of this process, certain light elements formed, such as hydrogen and helium. About 400 million years after the Big Bang, the cosmos slowly started coming out of its dark ages. This period probably lasted over 500 million years. Clumps of gas came together and formed something beautiful, the very first stars and galaxies. All this gave off lots of ultraviolet light. It was as if someone finally turned on a cosmic flashlight that cleared away the foggy gas that was all around. About 9 billion years later, our solar system got into the game too. It was born from this dense cloud of interstellar dust and gas. The cloud fell apart, possibly because of the shockwave produced by a star that exploded somewhere nearby in a spectacular supernova. This left us with a solar nebula, a disk of material that kept spinning. At its center, gravitational forces kept pulling more and more material in. At one moment, the pressure at the core became so great that hydrogen atoms started to mix and form helium. Like it happens with other processes in space, this released giant amounts of energy. And ta-da, we got our star. So big that it makes up over 90% of all the matter in our solar system. The remaining matter from the disk had its own job to do. It probably started off as grains of dust even smaller than the width of your hair. Gravity and other forces made clumps smash into one another. They got bigger and bigger. Particles of dust eventually evolved into pebbles, and then, as this donut-shaped disk of gas kept spinning, they turned into rocks. Meanwhile, the star pulled in nearby gas and pushed the rest of the material farther away. Those parts of the disk were far away from the sun, so water in those regions started to freeze. Soon, there were tiny pieces of ice flying around, gathering into dirty snowballs that became planetary cores. Since it was cold, gas molecules could slow down enough for a planet to draw them closer. That's how we got our famous gas giants, Neptune, Uranus, Saturn, and Jupiter. Jupiter and Saturn probably formed first, maybe even within the first 10 million years of the existence of our solar system. Parts of the disk that were closer to the sun remained warm. The material there gathered into rocky planets. After the icy giants appeared, not much gas was left for the other ones though. So, Mercury, Venus, Earth, and Mars ended up a bit smaller. They may have taken tens of millions of years to form after the sun was born. This is, of course, a very simplified version of how we got 8 planets in our solar system. Who knows if we'll ever know the whole truth? Time went on. Space debris was swirling around. Some objects became large enough for their gravitational force to shape them into spheres. That's how we got dwarf planets and big moons. Our asteroid belt is the region that separates inner planets from outer ones. It's full of pieces and bits from the early solar system that never grew into something bigger. They just kept on floating around, maybe waiting for another chance. Other smaller leftovers turned into comets, meteoroids, asteroids, and small irregular moons. 4.5 billion years ago, something else arose from all that chaos. A planet almost as big as Mars collided with Earth. And the debris formed the only moon we have today. Somewhere around that time, the Sun also got to a new level. At its younger stages, it was just a ball of helium and hydrogen that still wasn't powered by fusion. Over millions of years, it got hotter and more pressurized, and finally turned into the shining star we know today. It's supposed to stay like this for a very, very long time. Around 10 billion years. Simulations scientists have made to understand the creation of the universe show that the chaos of that time was even bigger than we thought. Orbits of the giant planets probably shifted during that period too. The gravitational force from many objects in the Kuiper Belt shook Saturn and Jupiter into a 2-1 resonance. That means Jupiter made a circle around the Sun twice for every Saturn orbit. This brought the two giants closer together, which wasn't good for their surroundings. There's a theory that Uranus didn't form where it is today, which is 20 times farther from our Sun than Earth. At this distance, there wasn't enough material to make the whole planet. That's why there's an idea that Uranus was born closer to the Sun before it got ejected farther away for some reason. Maybe that reason was the mess Jupiter and Saturn made. Some believe Neptune shares a similar destiny, together with the whole Kuiper Belt. As Uranus and Neptune were passing through the Kuiper Belt, they scattered most of the objects there. Any additional ice planets that had formed there also ended up kicked out, but in this case, entirely out of our solar system. Pieces of these scattered worlds that were located more outwardly stayed in the Kuiper Belt and the Oort cloud, a faraway sphere of ice bodies where the majority of comets come from. In all this chaos, the inner planets got hit. Scientists think that's how we got organics and water here on Earth. That's exactly what we needed for life to start developing, somewhere 3.8 to 3.5 billion years ago. We found evidence of microbes in the hard structures they made. Those are called stromatolites. They help us understand the earliest forms of life on Earth. Up until 3 billion years ago, Mars might have also been a good place for life. The red planet used to have a thick atmosphere and a strong magnetic field, just like Earth. But unlike our planet, Mars cooled from the inside, which switched off this whole mechanism. Without its magnetic field, nothing could protect the planet from the solar wind that pulled away most of its atmosphere in just a few 100 million years. Mars used to have magnificent lakes, rivers, and water streams that left traces we can see on its surface, even today. Luckily, Earth managed to keep its water, so life continued to evolve. 2.5 billion years ago, Earth got photosynthetic organisms that started pumping oxygen into the atmosphere and helped create the entire animal and plant kingdom across the planet. Another big thing happened in our solar system later. Saturn got its astonishing rings. No one knows for sure what happened back then, but a new theory says the rings aren't as old as the planet itself, only about 100 million years old. At the same time, something hit our moon and left Tycho crater, one of the most prominent craters on the lunar surface. Other planets couldn't avoid collisions either, including Earth. You already know what happened 66 million years ago. A giant asteroid triggered changes in climate and erased 3/4 of life, including dinosaurs.
At 12 a.m., young molten Earth collides with another planet called Theia. The moon is formed. From 12 to 4:30 a.m., the planet and atmosphere are morphing. The continents merge to form supercontinents. They break up again. This happens every 400 million years. That's every 2 hours on the clock. At 5:30 a.m., we see the first single-celled organisms starting their life in the ocean. It's 8 a.m. when the first viruses emerge. By 11 a.m., photosynthesizing bacteria have managed to take in enough sun to fill the atmosphere with oxygen. It takes 1 billion years. That's 6 hours on the clock. At 11:35, we have the first snowball Earth. Even the oceans turn to ice. Don't worry, everything will melt by noon. At 1 p.m., we have special cells with internal organs coming to life. 3 hours later, they'll start to divide into 3 groups that will eventually become fungi, like mushrooms. Let's fast forward while these cells go from simple to complex life forms. At 7:20 p.m., something familiar appears: sponges. It's 7:55 and the Earth freezes over again. It melts in 2 minutes. 8 p.m. and look in the ocean. We have the first comb jellies appearing. At around 8:30, the Earth's ozone layer appears. In just 2 minutes, the ocean is filling with plants. By 8:45, life is flourishing in the sea. We now have jellyfish swimming around corals. Starfish are on their way. At 8:52, we can see trails on the ocean floor. Creatures have begun to crawl. It's 9:10 p.m. The sea creatures decide to explore the land. 30 seconds later, different animals and plants emerge. They spread all over the planet in an instant. 9:41. It's time for the first insects. They feed on newly formed plants and trees on land. By 9:45, we have the first 4-legged animals appearing in shallow waters.
At 10:10 p.m., those four-legged creatures are splitting into groups that will later become mammals, reptiles, birds, and dinosaurs. By 10:30, everything vanishes. Mass extinction takes place. Either a huge asteroid or an enormous volcanic eruption causes it. Only 5% of the species survive. 10:34, and the dinosaurs are finally making an appearance. The first one was the Nyasasaurus, but experts aren't sure if it was the real deal or a relative turning into a dino. 1045 marks another mass extinction. The early dinosaurs survive it and take the opportunity to spread all around the world. In 5 minutes, the Tyrannosaurus will appear. By 11 p.m., we have the first birds appearing in Europe. It's 11:15, and mammals are splitting into their groups. They'll branch out, forming whales, elephants, armadillos, and primates. By 11:17, dinosaurs are reaching their full size. The biggest one ever is the Argentinosaurus. It's the length of 10 school buses and tall enough to peek into a 7th-floor window. It's 11:26 when a giant asteroid smashes into the Earth. Dust flies everywhere. A few seconds later, everything clears up, but the dinosaurs have already disappeared. With the dinosaurs gone, the few mammals left can take over the planet. At 11:30, the primates separate into 2 groups, and one of those will become apes, gorillas, and, sometime later, humans. It's 11:58 p.m. The chimpanzees and bonobos appear. 15 seconds later, the hominin species begins to walk on 2 legs. It's 11:59 and 23 seconds, the time when humans appear in Africa. A second later, they've migrated all over the world. They don't have a language, and they can't use or create tools. That happens at 11:59 and 58 seconds. 2 seconds before the day ends, 100,000 years ago, our complex human species appears.
All right, let's imagine that humans have evolved to survive on very little oxygen. That means the Earth is now a no-go zone for us. And let's say that now we can live only on planets with little to no oxygen. It's time to build new homes on Mercury and Jupiter. So let's explore what life would be like if that happened. As you set foot on Mercury, you'll immediately notice how crazily bright it is. Mercury, being the closest planet to the Sun, is a never-ending summer vacation. Right now, it's scorching hot at a sizzling 800 degrees Fahrenheit. But since we don't need any water or oxygen, our bodies have adapted to the blazing heat and dry conditions of Mercury. Instead of overheating, our skin possesses a special protective layer that helps us handle these conditions. So, we're able to live there without any discomfort. How cool is that? On Mercury, the air is very thin. As a result, the sky there appears mostly dark and empty. The surface, however, is pretty colorful. It can appear orange and golden due to the planet's rocky terrain and the intense sunlight. All this creates some captivating views. Our activities would be super exciting. The gravity on Mercury is very weak, almost 3 times weaker than Earth's. So, imagine gliding through the air with incredible wingsuits, effortlessly soaring above the molten landscapes. So many possible cool tricks to show off. The buildings in this world are both imaginative and practical. They're made of special materials that can handle the heat and shine with a metallic gold color, reflecting the scorching sunlight. As you can see, our life in this small, hot world can still be pretty exciting. But let's move on to Venus. Now we've got ourselves quite a workload. This is the wildest and wackiest planet in the neighborhood. Temperatures there sizzle at a mind-boggling 900 degrees Fahrenheit. But guess what? Our bodies are cool with it. We can handle extreme temperatures. The winds there are crazy fast, reaching speeds of 224 miles per hour. Amongst them, we spot mysterious dark streaks that refuse to budge. Even scientists are puzzled by these streaks, which soak up ultraviolet radiation. It's like Venus has some secret party tricks up its sleeve. And speaking of parties, the planet is packed with active volcanoes, and they're always putting on quite a show. Molten lava flows and fiery eruptions are our daily dose of entertainment. Venus is similar in size to Earth, so the landscape feels familiar, but with a twist. It has a crazy amount of pressure that would make even the toughest creatures on Earth squirm. But not us. Our bodies are built to handle it, and we confidently strut around Venus like it's no big deal. Our cities shine like beacons, built with materials that can handle the intense heat and pressure. The metallic structures reflect the fiery glow of the Venusian sun. Inside, we've got super advanced cooling systems that keep us comfy despite the scorching temperatures. We surf on streams of molten lava, safely of course, and explore the volcanic landscapes. Pretty exciting, isn't it? But still, how about moving to a more friendly environment? Like Mars. Moving to Mars is one of our biggest goals. Its surface is a colorful canvas with hues of brown, gold, and tan. It's covered in rusting iron, regolith, which is like Martian soil, and dust. We would also be surrounded by volcanoes, impact craters, crustal movement, and mighty dust storms. As we gaze into the sky, we're greeted by Phobos and Deimos, Mars's moons. The sky itself is hazy and painted in shades of red, and becomes blue during the sunset, opposite to what we have on Earth. The temperatures on Mars can be quite extreme. Sometimes it's as mild as a comfortable 70 degrees Fahrenheit, while at other times it plunges to bone-chilling lows of around negative 225 degrees Fahrenheit. But once again, let's assume that our bodies have adapted to handle these swings. We've also developed ways to safeguard ourselves from meteorites and asteroids. These guys will be our frequent guests. The thin atmosphere of Mars doesn't provide much protection from them. Out of all the planets, Mars would be the easiest one for us to adapt to. Our next candidates, though, are not that hospitable. Living on Jupiter, the gas giant is a whole new level of adventure. Since there's no solid ground to walk on, we've come up with some super cool ways to call this place home. Picture floating cities like gigantic bubbles, suspended in swirling gases and liquids. They're specially designed to withstand extreme pressures and temperatures. To get around, we have jetpacks and hovercrafts. Imagine floating amidst Jupiter's majestic atmosphere, surrounded by cold, windy clouds of ammonia and water. These vibrant stripes and swirls paint the planet with a colorful palette. We zip through the colorful clouds, enjoying a mesmerizing kaleidoscope. Our homes and cities are filled with vibrant colors and shimmering lights. We've even created artificial gravity zones, where we can experience a semblance of gravity and walk with a bounce in our step. But be careful. Jupiter's powerful storms can be intense. Luckily, we have advanced weather prediction technology that keeps us safe. We watch the mesmerizing light shows of lightning dancing across the sky, marveling at the raw power of nature. All this sounds pretty fun, doesn't it? Well, what about the next gas giant, Saturn? Once again, we can live in the skies of Saturn, right among its beautiful rings. Our cities are like big, colorful balloons that sparkle and shine with bright lights. Inside, we have large domes where we can freely enjoy everything this incredible planet has to offer. Instead of walking, we use special devices that make us glide through the air, just like on Jupiter. In this extraordinary place, we had to discover new ways to generate power. We use the energy from Saturn's powerful storms. These sources of energy help us fuel our floating cities, giving us the electricity and resources we need to thrive. Saturn has many moons, and each one has its own special features. We've set up outposts on some of these moons, where we can go on exciting adventures and explore their mysterious landscapes. But if living on a gas giant wasn't challenging enough, we also have ice giants in our system. Welcome to the fascinating world of Uranus. Despite the super chilly temperature of negative 353 degrees Fahrenheit, we've come up with clever ways to make this place livable. To create warmth, we can learn from Earth's greenhouse effect. Like a cozy blanket, we can introduce special gases into Uranus's atmosphere that trap heat. Another idea is to build gigantic mirrors to capture and reflect the sun's heat. But let's be honest, it would be quite a challenge to position all those massive mirrors just right. Our homes are designed to withstand extreme conditions. We use dense fluids like methane, ammonia, and water to build structures that keep us warm and cozy. Our habitats provide shelter from the freezing temperatures outside. We may even discover new forms of life that have adapted to the unique conditions of this icy giant. Now that would be chilling for sure. And finally, we have Neptune. It is the cool and distant cousin of the solar system. Neptune's atmosphere is mostly composed of hydrogen, helium, and methane. There's also no water, only lots and lots of ice. But that's fine with us, right? So it's time to construct habitats. Let's envision another sky city. After all, who doesn't love the idea of floating cities amidst the clouds? Imagine gazing out from your sky city, observing the mesmerizing hues and swirling storms of this ice giant. The vibrant colors of the atmosphere would paint a breathtaking backdrop for our daily adventures. We'd explore the mysteries of Neptune's moons, delving into their icy landscapes and uncovering the secrets they hold. Hey, a world where humans don't need oxygen or water to survive doesn't sound that bad. We'd soar through the skies and roam vast landscapes. The only limits we would have would be the limits of our own imagination. So stay tuned for more captivating what-if scenarios. An hour after people disappear, most urban areas will be left empty and quiet. Perhaps the sound of wind, falling leaves, or other natural sounds previously drowned out by city noise and traffic will be heard. The subways of many cities are protected from groundwater by a system of pumps. If there are no people to monitor such systems, most subways will flood within 36 hours. Due to malfunctions, sewage treatment plants will stop working, leading to pollution of rivers and lakes with wastewater. The water pipes in Detroit will become unusable, leading to the flooding of the city. Food in refrigerators will spoil. Raccoons and wolves will inhabit abandoned human homes. Major airports will be covered in rust and overgrown with ivy. Cruise ships in Alaska will sink under the weight of ice that accumulates on them. Lions from the San Diego Zoo will gradually escape, emboldened by the power outage of the electric fence around their enclosures. More and more black cats will appear on the streets of Rome and the Vatican. Rats and mice will consume all edible reserves and leave the cities. Plants will begin to grow in cracks in streets, highways, sidewalks, and buildings. More and more animals will notice the absence of people and flock to the cities. International Space Station will gradually decrease. Since no one will correct its orbit, the station will eventually fall to Earth and burn up. Along with it, digitized samples of human DNA will perish. A large part of the city's territory will be covered with a vegetation of lianas, grasses, and tree seedlings. The Red Square in Moscow will have a layer of soil and thick grasses growing, making the square completely green. Despite high levels of radiation, animal populations are increasing in abandoned areas. Plants have grown in many houses and buildings. Seawater will flood cities that were once drained by artificial drainage systems, such as London and Amsterdam. Satellites will begin to fall to Earth. Since no one maintained their speed of movement, they slowly approached Earth and eventually fell to the planet's surface. Wolves now roam freely around the Brandenburg Gate in Berlin, and wild boars will be seen in Paris. Human speech will be preserved in rare words that parrots have memorized during their years of living with humans. Snakes will not only reproduce at incredible rates, but also grow much larger in size. Their main prey will be rodents that have multiplied in the first years after humans disappeared. Many human-made structures will collapse within 100 years, primarily those with a large number of steel elements. Fruit Christmas cakes, thanks to their alcohol coating, will not only retain their appearance but also freshness. Most buildings will be overtaken by plants and animals, and the city will resemble more of a wild nature landscape. The period of nuclear fuel decay will come to an end, and as a result, dead zones around the ruins of nuclear power plants will once again become habitable. The last parrots that spoke human language may go extinct since they memorized human speech, but it is simply not necessary for their survival in the wild. All modern carriers of information that preserve human culture, laser discs, photographic film, paper, and the like, will turn to dust. Rebar inside concrete buildings, which are more durable than steel ones, will expand 3 times due to rust, causing the destruction of concrete structures. Most modern cities will be covered by a green blanket, and collapsed skyscrapers and buildings will become new hills. Manhattan will return to its former state before human settlement, with numerous streams and lakes. There will be almost no evidence of the existence of human civilization. Only powerful stone buildings that rely solely on the force of gravity will survive, such as Notre Dame de Paris. Of the products that existed during human civilization, only honey, especially in clay pots, and oil in wooden barrels, will be well preserved. only a few stone structures will survive, including the pyramids in Giza and the Sphinx, almost entirely buried in the sands of the desert, and fragments of the Great Wall of China. By this time, a new ice age will begin on Earth. It is expected that the KEO satellite will enter the atmosphere by this time. Various pieces of space debris will collide with it during its descent, but this will not destroy the satellite. Eventually, it will fall into the waters of the world ocean. Remnants of spacecraft and satellite debris will float through space as the only reminder of human civilization.
One day, NASA will build a spaceship that can take us anywhere in the universe. Probably. And when this happens, we'll be able to find a new, beautiful home. Scientists even know what exactly they're looking for. We want a planet about twice the size of Earth with an average temperature of 77 degrees Fahrenheit, with a pretty dense atmosphere. Bigger planet means more room for water and potential homes. And a dense atmosphere means more protection from nasty space stuff, as well as more lush plants and cool animals. Thanks to the James Webb Space Telescope, we can now study exoplanets better from a distance. Of course, sending astronauts there would be much better, but oh well. Discovering new planets isn't easy though. It's like trying to find a tiny firefly in a pitch-black forest. Scientists had to come up with a clever method to find very distant planets. It's called the transit method. Here's how it works. Scientists capture a series of snapshots of a distant star at different points in time. Then, they scrutinize these images. They try to find any mysterious dark spots passing in front of the star. If they find one, it could very well be a planet. These snapshots hold the keys to uncovering vital information about these distant worlds. Not only do they tell us that there's a planet there, but also reveal its size, radius, and how close it is to its parent star. And most excitingly, they hint at whether it could ever become a new home for us. And now their research is finally bearing fruit. Recently, we've stumbled upon a tiny world nestled in the Cygnus constellation. It's called Kepler 22b. At first glance, it might not seem like a big deal, but this discovery has some pretty huge implications. This planet is located right in the Goldilocks zone. The Goldilocks zone, also known as the habitable zone, is a sweet area around a star where the conditions are just right for a planet to have liquid water on its surface. It's not too hot, so it doesn't evaporate, and it's not too cold, so it doesn't freeze. Hence the name from the famous story of Goldilocks and the Three Bears. So there might be water on Kepler 22b, and where there's water, there's a chance for life. And it's not just about life. Having a planet covered in oceans can be a game changer for climate stability, all because vast water bodies act like nature's thermostats. When the sun beats down on the hot parts, the water soaks up some of that heat and spreads it around like a blanket. The scorching regions cool down and the icy ones warm up and thaw out. Back in the bad old days of our Earth, the moon played a crucial role in helping water puddles spread across our planet. This is what helped our world transform from a fiery nightmare into the vibrant, life-packed orb we call home. Kepler 22b has about the same year length as our Earth. And if we're right about the whole ocean thing, scientists think its average temperature could be around a cozy 12 degrees Fahrenheit. But if this world also sports an Earth-like atmosphere, temperatures might soar up to a toasty 72 degrees. This world isn't too far away from us, only 635 light-years, which is about 3 quadrillion miles. Yeah, that's pretty close in space terms. Its sun is a yellow dwarf star, just like our sun, although there's a subtle difference. It's about 20% dimmer, so you won't see this star in the night sky even if you squint your eyes really hard. This star also happens to be quite chilly. Its temperatures are hovering around a frigid 10,000 degrees Fahrenheit, making it the Arctic of the starry skies. Luckily, Kepler 22b snuggles up to its star a bit more closely than we do to the sun. If it was in our solar system, it would find its place somewhere in between our familiar Earth and Venus. So the brightness and the temperature on this planet would be almost the same as on Earth. There are a couple of catches though. For example, this world might be quite a gymnast. It could be twirling around its star in a totally different way than Earth does. It might be tilted, like Uranus. If that's the case, the temperatures of the planet could be quite weird. You'll experience bone-chilling winters, followed by scorching hot summers. So let's hope this theory isn't true. If Kepler-22b has a normal tilt, its climate would be pretty similar to what we enjoy here on Earth. The next problem is gravity. Kepler-22b is about 2.4 Earth's size, which means the gravity there would be stronger. You'd feel noticeably heavier on this planet. It would be just like doing your everyday activities on Earth, but everything would require more effort due to the stronger gravitational pull. Simple things like climbing stairs or even just breathing would require much more energy. So it's time to build some muscles. People would have to adapt to the new conditions by having denser bones and more robust cardiovascular systems just to move around comfortably. Unfortunately, that means doing sports would be much harder too. But hey, at least people might need to consume more calories to sustain their activities. So even though you'd have to exercise more, you'll also be able to eat more delicious food. Buildings on Kepler-22b would likely be square and robust to withstand the stronger gravity, which would kinda be problematic because taller structures are super challenging and expensive to build. But the most important question is, what kind of planet is that at all? Yeah, it's the big question mark. Scientists aren't even sure that Kepler-22b is Earth-like. It could be a gas giant, or even a water world. A water world is a planet with a vast ocean covering its surface, and it's not just some knee-level deep water. It'll be insanely huge, thousands of miles deep and more, with no visible surface or any plants around for a long time. In that case, we could dream of building underwater cities. We could filter the water for sustenance and perhaps evolve into amphibious beings. Would that be a step backward or a leap forward in our evolution? Some scientists also lean towards the idea that Kepler-22b might be a mini Neptune. This is a legit planetary category, by the way, but that theory is still unproven. But let's say, for our sake, it's a rocky planet. Even then, we're in the dark about its atmosphere. Does it even have one? What if it's like Venus, toxic enough to make your ex look like a bouquet of roses? In that case, we'd have to dig deep into the planet's depths for survival, figure out a heat source, and hope for the best. While there's a lot we don't know, let's keep our fingers crossed and assume the planet is Earth-like. In that case, what would Kepler-22 look like? Well, because of stronger gravity, the planet's landscape might be full of rugged mountains, deep valleys, and powerful rivers. If there's life on this planet, it's probably quite small? Unusual plant and animal life should have adapted to the higher gravity. Trees might be shorter and sturdier. They'd struggle to break free from the soil. Animals might be pretty small too. They would also have strong, muscular legs for support. Perhaps these creatures would have numerous legs, making movement possible. They'd need to be small in stature, but gargantuan in strength. Muscular giant spiders sound not so bad, right? As for our beloved pets, they'd have to become little muscle-bound spheres just to survive. Also, the landscapes would feel very spacious because of the planet's sizes. A 3-day flight in a plane sounds like quite the adventure. There are many possibilities with Kepler-22b. So far, we don't have a clear answer. But let's hope that scientists will find it before we load the first people into shuttles and send them to conquer the planet. That would be awkward if it turns out to be a gas planet or something like that.
Picture this. It's a lovely Sunday morning, and you rise from your bed, do some stretching, and open your window to a gorgeous day with clear skies. But hold up, something's odd here. The usually jam-packed street is completely deserted. Where did everyone go? You take a closer look, and to your surprise, you realize that you're the only soul on this planet. What's your next move? Let's get real here. The answer to that question is simple. You can do anything and everything that your heart desires. The world is your playground, and you can create your own adventure. Want to drive a sports car at lightning speed on the freeway? Go ahead, because there's no traffic to hold you back. Feel like playing a round of golf from the top of a skyscraper? Why not? Who cares if you end up breaking a window or two with your golf ball? Have you always dreamed of living in a massive mansion? Guess what? Now you can. You have a world of possibilities in front of you, and nothing can stop you from experiencing them all. Okay, so you've had your fill of all the excitement and thrill, and you're now starting to ponder on the question of what's next. Maybe it's time to get down to business and figure out the reason behind the world's sudden emptiness. Could there be anyone else out there? What if you're not the only one left? You might start searching the city, and even venture beyond its limits. But the world is a big place, and you might not come across another living soul. That thought alone can be a bit terrifying, right? So let's move on to more important matters, such as how you're going to survive in this desolate wasteland that's now your kingdom. It's time to face reality and plan out your next steps to ensure that you can make it through this situation, no matter what. The first thing on your to-do list is finding food and clean water. Of course, you'll have a good supply of both for some time, but perishable items such as fruits and vegetables won't last forever, so it's best to consume them first before they go bad. After all, there's nobody operating the power stations that power the refrigeration units in grocery stores, so they will inevitably shut down. Speaking of which, you also need to consider your water source. In the initial stages, try to scavenge every single bottle of water you can find from the nearby stores and bring them back to your sanctuary. But, unfortunately, you'll eventually run out of bottled water, and you'll have to come up with a way to filter your water supply. This will be a vital task to ensure your survival in the long run. Think of laying your hands on a portable water filter like this one. With that, you will be able to take water from any source, be it a river or even a hole you dug up yourself, and drink it in no time after it's been cleansed in this bottle. So you've indulged in all the perishable food items you had stocked up on for days, weeks, or maybe even months. Now it's time to start thinking about the future and your long-term food supplies. Since there's no electricity to keep your fridge and freezer running, you're going to have to rely on non-perishable food items such as rice, beans, and canned goods. These will be your trusty companions in your quest for survival. However, as time passes, you'll need to think about sustainable food sources, and that's where farming skills come into play. You should start learning how to grow your own food before your stocks run out completely. Let's talk about medical supplies. They're a crucial aspect of surviving in a world where there's no one to turn to for medical assistance. Your best bet is to raid as many pharmacies as you can find and stock up on future supplies to prepare for any potential emergencies. It's essential to be extra careful too, since there won't be any doctors around to help you out if you sustain serious injuries. When you're the last human on Earth, you're going to need to learn a whole bunch of survival skills if you want to keep on keeping on. I'm talking hunting, first aid, cooking, and plenty more. It's not just about farming and filtering water, although those are important too. Right now you're probably relying on a bunch of other people, without even realizing it. But in this new world, you're going to have to fend for yourself. The good news is that you've got all the time in the world to learn new things and expand your knowledge. Remember those libraries and bookstores you used to walk past without a second glance? Now they're your ticket to becoming the ultimate survival expert. And yeah, you won't have the internet to help you out, but you'll learn to do things the old-fashioned way. You might also want to have some survival gear with you at all times. You may get in all sorts of trouble with nobody to help you but yourself. So having a hiking toolbox like this one could be a lifesaver. It has everything you need to find your way and stay warm and safe even in the wild, not to mention the city. As much as you may enjoy the solitude, you're gonna need some sort of companionship eventually. Sure, you could get yourself a pet or two, or even build your own personal zoo if you're feeling ambitious. But be careful. You don't want to get eaten by a pack of wolves or lions, do you? Maybe just stick with a dog or a cat, or perhaps a bird that can mimic your voice so you can pretend you're having a conversation. Either way, you're gonna need some sort of connection with another living being, so start thinking about your options. So, you've got this whole world to yourself, right? And you can live in any mansion, palace, or hotel you want. Sounds great, doesn't it? But let's be real here. Living in luxury all the time can get old fast. Plus, these buildings will start to crumble and fall apart if there's nobody to take care of them. maybe run away from the city altogether then. You can go anywhere, the world is your oyster. But before you start packing your bags, remember that you need to find a way to get there. The problem is that all the cars and trucks will be useless because their fuel will go bad after a few years. So, you might want to choose a place to settle down for good. And in my opinion, it's probably a good idea to avoid places with extreme weather conditions. I mean, dealing with a hurricane, blizzard, or tornado all by yourself doesn't sound like a walk in the park. Don't forget about the clothes. Yeah, I know, you can totally raid all the stores and try on all the funky outfits or dress like a celebrity for a while. But let's get real. You're gonna need clothes that will actually help you survive. So make sure you have something for every season, and keep plenty of warm clothes and blankets around. An emergency blanket may come in handy as well. Stock up on these just in case. It doesn't take much space and can save your life. Even if you move to a place where it's hot all the time, it can still get chilly at night, so you gotta be prepared. Hey, I know talking about being the only human left on Earth can be a total bummer. So let's switch to the brighter side of things. With nobody around, you can find all kinds of ways to entertain yourself. Sure, survival skills are important, but you can also learn new hobbies and get creative. Imagine learning to draw, make sculptures, or write your own book. You could be the next Stephen King, except without any competition. What would you call your masterpiece? The Lone Survivor? The Ultimate Survival Guide? The possibilities are endless. Just don't forget to keep talking to yourself or your pet parrot so you don't forget how to use your own voice.
You wake up with a start, open your eyes, and look around. Oh, you're inside your sleeping capsule. Its walls are littered with different buttons and tiny screens. You press one of them, and one of the sliding panels sweeps to the side. You crawl out of your pod and start another regular day on the moon. Or maybe you open your eyes and come up to the window to have a look at the weather outside. Everything seems to be as usual: blue trees, purple sky, and low-hanging yellowish clouds. Great, you won't need your acid rain protection today. Or maybe you'll open your eyes to the dry plains of the Red Planet. You'll eat your 3D printed breakfast and set off on a trip to Olympus Mons, the largest volcano on Mars. You've been planning this climb for ages. Whatever scenario it is, one thing is glaringly clear: you're not living on Earth. Why? There might be a few reasons why people could have abandoned our beautiful green paradise. The sun might have grown too old and started to expand, burning vegetation, boiling the oceans, and leaving Earth uninhabitable. Or it was probably a collision with the Andromeda Galaxy. Yes, the one that is bound to crash into the Milky Way in about 4.5 billion years. It could have been a wandering asteroid, large enough to destroy all kinds of life on our planet. Of course, these days, astronomers have their own ways of spotting such space intruders. But what if their equipment malfunctioned? It would end badly for Earth and Earthlings. A much sadder reason for us to leave our beloved planet would be our own actions and the risks we pose to it. According to statistics, these days, the onslaught of droughts, earthquakes, floods, and epic storms is triple the number from the 1980s and almost 54 times that of 1901. Climate change could lead to water shortages, a severe lack of food, and the submersion of coastal regions. If it all went too far, we'd have to conserve the planet to save at least some of its flora and fauna. Then, it would become a nature reserve the remaining people would sometimes visit. But if not on Earth, where would humanity live? Surprisingly, there are quite a few options. For example, we could dig several feet beneath the surface of the moon and build our bases there. Or the first towns on the moon might be built in craters and covered with protective materials, like plastic reinforced with a net made of titanium and UV-resistant superfiber. The inhabitants would have to access their homes through airlock entrances dug into a mound. Or we could skip the moon altogether and set off towards the moons of Jupiter, Saturn, Uranus, or Neptune. Yes, they're much farther from the sun and probably way too cold for us. But on the bright side, these moons are believed to contain vast amounts of water, carbon, and nitrogen. And still, the most likely destination is Mars. Unlike the moon, which has a very, very weak atmosphere that consists of unusual gases, Mars has a bit denser atmosphere, even though it's still about 100 times less dense than the atmosphere of our home planet. In any case, it can offer us some protection against harmful space radiation. Mars also has about 40% of Earth's gravity, which is not that bad. We could probably get used to it with time. Plus, there's water ice on the red planet. The soil there contains enough carbon to grow plants. With time, the planet could be terraformed with the help of water from underground ice or imported from an ice asteroid. We'd use this water to form a thin ocean and maybe even create a breathable atmosphere. Or we could find an exoplanet that has all the resources to support life. An exoplanet is a planet outside our solar system. It would probably be much easier for us to find a world that would be perfect for us, rather than reconstruct the already existing world with its own workings. You wake up with a start, feeling disoriented. You were dreaming of waterfalls and green fields just a moment ago, but now your body is tingling weirdly. It feels as if you don't have enough oxygen to breathe, which makes you panic a bit. You open your eyes and look around. Oh, you're inside your sleeping capsule. Whew! Its walls are littered with different buttons and tiny screens. You press one of them, and one of the sliding panels sweeps to the side. You crawl out of your pod. The absence of your windows or any natural lighting makes you feel as if you're underground. Dozens of sleeping capsules line the walls. The door leading out of the dorm is made of metal. It looks heavy and unmovable. But once you press the button on the wall next to it, the door opens smoothly and soundlessly. After walking up a dimly lit corridor for a while, you find yourself in a smaller room. There's at least half a dozen bulky spacesuits inside. There's another door in the room. It looks even sturdier than the previous one. If you wanted to open it, it wouldn't budge. First, you need to put on one of the spacesuits. As soon as it's on, the door automatically unlocks. After waiting for a while in an airlock chamber, you finally make a step outside. You look up and see a beautiful blue orb. It seems to be glowing. It's Earth, and you're standing near your home base on the moon. You walk towards your Jeep. It looks nothing like cars on Earth, though. The vehicle you climb into is pressurized, and you can even take off your spacesuit, or at least your helmet, and ride in comfort. If you need to go outside, well, yes, you can't do it without wearing your protective gear. One of your favorite rovers, produced by Toyota, is the size of 2 microbuses and can easily fit 2 passengers and their gear. Of course, you've got the experience of riding it with 3 other companions, but duh, you were squashed like sardines that time. The vehicle can also unfurl solar panels to generate power. After dealing with all the tasks you had on your list, you come back to your lunar home. Unlike your house on Earth, it looks more like a castle. Due to the extreme temperatures on the moon, the lack of oxygen, the constant threat of meteorites, and the never-ending barrage of radiation from the sun, it has to be super sturdy. The thing is, on Earth, we're protected by the atmosphere. Most meteorites burn while passing through it, and it also protects Earthlings from harmful ultraviolet radiation and creates the pressure without which liquid water couldn't exist on the surface of the planet. On the moon, there's no atmosphere like that. The very weak one that exists on our natural satellite is made up of some unusual gases that haven't been found in the atmospheres of Earth, Mars, or Venus. That's why people living on the moon have to take care of these issues themselves. The first towns on the moon were built in craters and covered with protective materials, like plastic reinforced with a net made of titanium and UV-resistant superfiber. The inhabitants had to access their homes through airlock entrances dug into a mound. Bilbo Baggins would surely appreciate their aesthetics. On the moon, gravity is way weaker than on our home planet. And while it makes it easier for you to walk and even run on the satellite surface, even despite your bulky spacesuit, it's not great in the long run. That's why inside lunar bases, there's an artificial gravitational field. Without it, people would have problems with coordination, balance, and orientation in space. Plus, weight-bearing bones would lose 1% to 1.5% of mineral density per month. And there would be many other problems with health. Anyway, these days, along with old settlements located in craters, there are new towns that look like transparent glass spheres. They make a beautiful picture when you look at them while approaching the moon after visiting your family on Earth. Next to many of these domes, you can spot tall sun-reflecting towers. They can simulate the day cycle to help human bodies function properly, as they used to be on our home planet. Inside, there's a breathable atmosphere and fixed atmospheric pressure. The floors look as if they're made from regular concrete, but the material used in the construction is lunar dust. A colony on Mars would cost us trillions of dollars to construct and inhabit. It would take a long time for even one cargo ship to reach the red planet. But lunar towns are much easier to build and maintain. There are direct spaceship routes connecting the satellite with Earth. And you need just 3 days to travel between these 2 points. That's one of the reasons the colonies on the moon are growing, developing, and changing non-stop. When people first came to the moon with the intention of building settlements, their main concerns were producing energy and getting oxygen and water for a comfortable life. Now, you have trash can-sized nuclear reactors that provide the towns on the moon's surface with steady power. Plus, in some regions of the satellite, for example near the South Pole, there is near constant sunlight, which is great for getting solar power. That's one of the reasons why most lunar settlements are built in that area. Another thing that makes colonizing the moon easier is its ice. People living on the satellite use it to make hydrogen-oxygen rocket propellant. The main way to get the raw material is by using the regolith and ice drill for the exploration of new terrains. That's a piece of equipment designed for drilling in ice-cemented regolith and rock. This fuel is then used for cargo and passenger ships coursing between Earth and the moon. Right now, people are trying to derive oxygen and other useful products from lunar soil. More than 40% of the lunar crust is composed of oxygen. Of course, it's bound up in minerals in combination with other elements. These compounds are called oxides. You might have heard of quartz, aka silicon dioxide. It's the second most common mineral in Earth's crust. To move from one lunar town to another, you use moon Ubers, taxiing people and cargo. They're also called all-terrain hex-limbed extraterrestrial explorers, or athletes. They have 6 limbs that can grip cargo and roll or step over obstacles. Plus, they can switch out quick connect gripping and digging tools if you need them. They also carry people to and from launch pads, acting as lunar airport shuttles. But lunar towns aren't just placed where people live. They're innovative research hubs both for industry and science. They're also a popular tourist destination. Plus, people living there are tirelessly working on developing and constructing a special base for future Mars missions and the exploration of distant space. But let's have a look at how it all started. For instance, how the first lunar bases were built. Private landers descended on the surface of the moon and deployed inflatable modules, each around 4 stories tall. They served as residential areas, workspaces, industrial sites, and scientific labs. But those modules couldn't completely protect their inhabitants from harmful radiation, temperature swings, and the strikes of micrometeorites. So, people developed robots that could 3D print protective shells around each inflatable module. They used readily available regolith taken from the surface of the moon. It took the robots about 3 Earth months to finish solid domes. Some of these settlements were later connected with one another through a series of walkways linked to airlocks in each dome. At the same time, some of the towns remained separated, like those constructed in craters. When you visit Earth, you often look up at the sky, searching for your new home. Some of the lunar bases are visible if you're looking at them through a telescope. Others, partially hidden underground or covered with lunar rocks and soil for better protection, are almost impossible to spot.
Heh, there's water on that there moon. No, really? But of course you knew that, right? However, NASA didn't know there was water on the moon when Apollo astronauts went to the moon 50 years ago. The astronauts brought back 842 pounds of rocks from the moon in hermetically sealed bags. When some of the hermetically sealed bags had water in them, NASA thought the bags had gotten contaminated from landing in the ocean. It was moon water, but NASA never made the connection that the water came from the moon rocks because, hey, there's no water on the moon, right? We now know that that's wrong. There definitely is water on the moon. However, who discovered that there is water on the moon is a bit of a tangled question. India claims that their Chandrayaan-1 lunar orbiter discovered water in the moon's soil. Regolith is the geologic term during its 2008-2009 mission. That claim is disputed because the Chandrayaan-1 spacecraft took only infrared spectral readings of the lunar surface at 3 nanometers. The positive results could also indicate OH molecules as well as H2O. OH is a hydroxyl, meaning it could be either an acid or an alcohol. India sent Chandrayaan-2 to the moon in July 2019 to confirm the earlier findings, and did find H2O by taking infrared spectral readings at 6 nanometers. But NASA's SOFIA laboratory claimed it found water on the moon in August of 2018. SOFIA, the Stratospheric Observatory for Infrared Astronomy, flying at 45,000 feet aboard a modified Boeing 747 SP, took 6 nanometer spectral readings of the lunar surface and found the clear signature for water in August 2018. However, there is some dispute about that too. SOFIA's readings were not consistent with variations in temperatures on the moon. So, what's going on here? It's there, and then it isn't. Clearly, a hands-on measurement of the temperature on the lunar regolith is necessary to pin down if and when water is present in the sunlight on the moon. Therefore, the blue ribbon for the definite discovery of water in the rocks and soil on the moon must be given to China's Chang'e 5 lunar rover working on the moon's near side in 2020. The question becomes, how much water is in the dirt and rocks on the moon? The answer? Not much. About 1 drop of water could be squeezed out of every cubic meter of regolith, and just slightly more in the rocks. Engineers are currently scratching their heads, trying to figure out what kind of machinery to design and build that will be able to mine this moon water. It is essential that the water be found locally on the moon. Water is too heavy to bring in any large quantities up to the moon to supply human activity such as building a planned moon base. Without a water supply, long-term human presence on the moon is a definite no-go. Fortunately, water is believed to exist more abundantly on the moon in another location, at the moon's south pole. As early as 2010, NASA radar mapped the polar regions of the moon. Radar mapping depends on the bounce-back or reflective signal of the radar waves. Radar bounces back differently when it strikes land or water or ice. Just like with your eyes closed, you can tell if someone is knocking on metal, wood, or plastic. The sound waves have their own distinctive pattern, just like radar does. The amount of time it takes to receive the bounce-back signal creates a map of the surface topography. Mountains, valleys, and ridges can all be mapped accurately, creating a detailed surface map. When passing over the craters of the lunar south pole, the radar-ranging reflection bounced back with a signal that indicated ice within the craters. This was big news and a thrilling finding. It is a peculiar quality of craters at the moon's south pole that the sun never shines down into the craters. The angle of sunlight merely skips horizontally across the tops of the craters, never going down into the craters. The unique polar location creates a situation where the upper rims of polar craters are always in the sunlight, but the bottoms of the craters never receive sunlight. Ice at the bottom of the craters will never melt. Over 40 permanently dark craters lie in the vicinity of the lunar south pole, and they all appear to have ice in them. Space agencies from all around the world quickly made announcements that they were planning moon bases at the lunar south pole. China, Russia, Europe, and Japan are planning to place solar panels around the rims of the craters, since they have sunlight 24/7, and mine the ice at the bottom of the craters. NASA was not so quick to do that. Wisely, NASA chose not to make extravagant plans based on a single observation. It's just not good science. Multiple observations are necessary. If your cousin Billy at dinner sees the salt shaker levitate and float in the air, but no one else notices it, it might not have happened, no matter how much Billy insists it did happen. Multiple observations are necessary for something to be considered real, and at least one of those observations must involve direct contact. NASA launched the Lunar Reconnaissance Orbiter to orbit closely over these craters at the Moon's south pole. Of the 7 LRO instruments taking detailed readings is the LAMP instrument, which can take ultraviolet images of the dark craters as they are illuminated by sunlight. Pretty clever. Current thinking estimates that there is 1 trillion pounds of water ice in the permanently dark craters at the lunar south pole, or about 500 billion liters of water. This is close to about what the whole United States uses in just 2 days. But for a moon base, 5 billion liters of water could last 1,000 years. Now, how did this ice get there? Comets are the best explanation. Comets can be composed of many different kinds of ice, water ice being the most common, since oxygen and hydrogen are so prevalent in space. Earth is the only place in our solar system, however, with Italian ices. When a comet crashes into the lunar south pole and makes a crater, the ice is trapped there, never to melt or evaporate since it is compacted into the moon's surface. Radar readings have indicated ice as deep as 60 feet below the surface at the bottom of these dark craters. It's going to get very crowded at the moon's south pole when all these countries begin carrying out their plans to exploit the perpetual sunlight on the crater rims and the ice at the crater's dark depths. The moon's south pole is fast becoming the most valuable and most coveted piece of real estate outside of the Hamptons on Long Island, New York. But NASA still hasn't gotten its final direct sensation of water ice at the lunar south pole. They tried, and NASA is still trying. The L-Cross spacecraft fired a heavy projectile down into the dark crater Cabeus. The idea was to create a plume of gas from the impact that would rise above the crater rim, and a following spacecraft would fly through the plume of gas and take direct measurements of it. This would be the physical proof of water in the polar craters that NASA was looking for. L-Cross found plenty of hydrogen, along with sodium, mercury, and silver in the gaseous cloud raised from the crater floor, but no H2O molecules. The amount of hydrogen in the plume led many scientists to insist that water ice had to be the source. But there was still room for some doubt. It was not the direct detection that NASA had hoped for. Coming soon, Prime 1 will drill for ice at the moon's south polar area. PRIME is an acronym that stands for Polar Resources Ice Mining Experiment. The probe will only be able to drill 3 feet deep, but NASA hopes that it is deep enough to find ice compacted into the moon below the level of the regolith. Prime 1 is part of, and a prelude to, the Artemis human crewed mission to the moon. NASA has not had boots on the moon in over 50 years. In fact, we haven't landed anything on the moon during all the years since the last Apollo mission in 1972. We have landed rovers on Mars many times in the intervening years, but not the moon. Now, with the almost certainty of water ice on the moon, the race is on to set up a human crewed station at the south pole of the moon. Water on the moon is not only creating a lot of excitement in the science community, it's also creating a lot of drama on the ground. So, now you are informed. It's not going to be just another space launch. This is a biggie. We're going back to the moon. It's going to be awesome.
Look up when the sky is clear at night. You'll see thousands of tiny bright dots there. It may seem like they're fixed in one spot, but in reality, they're constantly moving. In 100,000 years, there won't be a constellation with the same shape or pattern we know today. And think about all those red dwarfs, small stars, planets, space bodies we can't see with the unaided eye. Red dwarf stars are especially cool. They're usually about half the size of our sun, and mostly 1/10 as bright. They may not be the brightest things in the sky, but they live for a very, very long time. Nuclear fusion reactions happen deep in star cores. That's what makes them shine. Large stars release huge amounts of energy, burning their stellar fuel. But such stars tend to burn all their fuel in only a couple of million years. Stars like our sun usually live for about 10 billion years, but red dwarfs don't use that much of their fuel. Their light is not so powerful, and they don't require much energy to support their existence. They're like energy-efficient cars. That's why they can last hundreds of billions of years. Some of the smallest ones may live for up to 10 trillion years. Most hydrogen in sun-like stars remains unspent. There's more of this gas in the atmosphere rather than in the core of such stars. This means most hydrogen doesn't take part in the fusion reactions. But it's different with red dwarfs. They circulate plasma throughout their entire bodies. These stars pull fresh hydrogen reserves from their outer layers into their core. That's what keeps fusion reactions running. One day, in the distant future, stars like our sun will run out of fuel and shut down. The universe will be full of small red dwarfs. They won't have enough energy to shine and brighten the space around them. Our descendants, if there are any, will inherit a dim, dark cosmos. As it gets older, the sun will balloon to a size where it will destroy nearby planets. First Mercury, then Venus, and then us. On the other hand, Earth will probably survive, but barely and not for long. The sun will burn it to a crisp when it gets closer. The outer planets of our solar system will also survive, but they'll move even farther away into space. The sun will lose some of its mass while increasing in size. Its gravitational pull establishes the orbits of the planets. When our star becomes less massive, the pull of its gravity will become weaker, and the outer planets won't have such a strong connection with the sun. Our solar system is not isolated. There are many other stars in our galaxy. Within 30 billion years, stars that travel nearby will mess with our outer planets, enough to rapidly launch some of the biggest ones out of the solar system altogether. The last planet to stay will stick around for a while longer, maybe even 100 billion years. But even that one will eventually end up kicked out of the solar system. There's a theory claiming that we got most of the water on our planet from ice-laden meteorites and comets, frozen balls of ice and dust. As they crashed into the early Earth, they probably brought water, which was necessary to develop life. But those very same objects that might have created life on our planet could also be its end. This is not a matter of if, more a matter of when. And scientists think it's very likely that an asteroid or comet big enough to wipe out life on Earth will smash into our planet. But it'll happen in the distant future. And fortunately, we have the technology to predict such things and react on time. But there are other cosmic collisions we can't avoid, no matter what we do. Andromeda, our neighboring galaxy, is moving toward the solar system at a speed of 68 miles per second. There are 2.5 million light-years between the Milky Way and Andromeda, so luckily our neighbor won't cover that distance anytime soon. It'll only happen in around 4 billion years. Such a collision of two galaxies might lead to real chaos for our descendants, if any of them are still living on Earth, that is. The two galaxies will slide past each other. Then they'll draw apart until the gravitational force starts pulling them back together. As they merge, they'll both lose their disk-like structure and form one big elliptical galaxy. It's already got the nickname Milkomeda. The Milky Way as we know it today won't exist anymore. Space is in constant motion, changing all the time. Scientists have a couple of possible scenarios of what might happen with the universe in the future. Number 1, the Big Rip. This theory claims that the universe will expand infinitely. At one point, the pull of the expansion will get stronger than the gravitational force keeping it all together. If this happens, it will tear apart galaxies, stars, black holes, and all other space bodies, including Earth. The universe will turn into a bunch of disconnected particles. Until about 5 billion years ago, the universe was expanding slowly because of its powerful gravitational pull. Then its growth sped up. Some experts say it happened because of the effects of dark energy. Dark energy is a mysterious force that makes up almost 70% of our universe. This force pushes it to expand faster rather than slowing it down. So, in the case of the Big Rip scenario, dark energy will win over gravity to the point where it will be able to rip apart individual atoms. Scenario number 2, the Big Crunch. There's a possibility the universe will get to the point where it'll stop expanding. Gravity will become a dominant force. It might even reverse the expansion of the universe. Then, the cosmos will start shrinking, making planets, stars, and even entire galaxies collide. In the end, the whole universe will collapse in on itself. Once everything compresses into one infinitely small point, which is something called the Big Crunch, the universe may start expanding once again. Theory number 3, the Big Freeze. Brr. In this scenario, entropy will grow until it reaches its maximum value. Entropy is basically the idea that everything in the universe declines into disorder at some point. Once entropy gets to its maximum, the heat in the system will be spread evenly. The universe will then disappear because there won't be any room for heat to exist. Any mechanical motion inside the universe will stop. The cosmos will be so empty and gas will be so thin that no new stars will be able to form or shine again. In such a cosmos, time is just an endless void. Nothing ever happens with planets, stars, or living beings. The entire universe is frozen, dark, and motionless because there's no energy that can make things start working again. Many, many billions of years after the last stars burn out and fade, black holes will send a message that the universe has come to an end. Black holes are areas with extremely strong gravitational pull, so powerful that nothing can escape it. They can be as massive as 100 suns. As for supermassive black holes, their mass can be greater than that of 1 billion suns. You can find such giant black holes at the center of most galaxies. Like everything else, black holes will experience the same end. But when their moment comes, they won't gently disappear into the night. Black holes will go away in enormous bursts of fireworks, lighting up the universe in the last moments of their existence. It will be the end of the entire era. Black holes usually survive by gobbling down the stars and gas that come close enough. Their gluttony is the main feature that gives them away. In most cases, there's an accretion disk around a black hole. That disk is made of all those materials and particles it's torn apart and is pulling inside, similar to when water swirls down a drain. As the materials and particles draw closer, they start to move faster and faster. This generates heat, which makes the accretion disk glow, which again gives away the black hole. Yep, black holes aren't that great at hide and seek. Things that cross a black hole's event horizon, which is also called the point of no return, are lost forever. But Stephen Hawking had a theory that you might be able to escape from a black hole. There are particles moving even in a vacuum. Let's say one particle has positive and one has negative energy. If they both come close to a black hole, there's a chance that one will fall into it while the other will escape. That means the black hole has radiated the particle away. And this particle has taken some of the black hole's mass with it, which is why the black hole may start shrinking. As it begins to evaporate, it loses its mass and slowly becomes smaller. More and more particles start leaving until all the energy that's left behind escapes all at once. In the final tenth of a second, there will be a giant flash of energy and light in a very, very small region of space. And then, it's all gone.
84 million years ago, many modern mammals, birds, insect groups, even the first flowering plants are already there. Dinosaurs are still roaming around. They have around 20 million years left before the asteroid. T-Rex, a fearless hunter, becomes the king of the dinosaurs. In the Earth tilted by 12 degrees. Picture our planet as a chocolate truffle. The shell is hardened, the center is viscous, with semi-solid matter. Its top layer, the crust, consists of tectonic plates that are like puzzles. Continents and oceans come on top of these plates. 84 million years ago, the mantle and the crust started rotating around our planet's outer core, then going back. If you'd been able to see it from space, it would have seemed like the entire planet has tipped over on one side. Today, it would have moved New York City to where Florida is. Let's say our planet is like a spinning top. It whirls perfectly if the weight on the top is evenly distributed. But if you move some of the weight to one side, it makes it tilt. It may have been caused by the moving of the tectonic plates and one of them sinking under another. We might be drinking water older than our solar system. Some scientists think the water we have on Earth may have come from ice specks that were floating in some sort of a space cloud more than 4.5 billion years ago. Lakes aren't always peaceful and relaxing. They can also explode. It happens when there are volcanic gases under the surface that can burst, rise to the surface, and cause big damage. The Earth's rotation is slowly going through time. Every year, the moon gets a little bit of energy from our planet and slowly drifts farther away from it. These two things are making our day longer, but really slowly, around 1.4 milliseconds every 100 years. That means when dinosaurs were around, the day was 23 hours long. Our planet used to be purple. One theory says ancient microbes didn't rely on chlorophyll to absorb the sun, but on different molecules. They absorbed green light and then reflected back a nice purple color. Every time you take a dip in the ocean, remember you're swimming above more than $700 trillion worth of gold. Not on the ocean floor waiting for someone to get it out, but in tiny particles dispersed in the water. The deepest place on our planet is the Mariana Trench, a spot in the Pacific Ocean, 36,201 feet under sea level. But the deepest place that's not covered in the ocean is in Antarctica. Technically, it's hidden below thick and deep layers of ice, goes more than 8,300 feet below sea level. There are 60 tons of dust falling from space to our planet every day. You probably inhale a pretty good amount of this cosmic dust while just going to work. It's dust, small particles from comets, meteorites, and some other space bodies. Dalal, Ethiopia, is the hottest inhabited place on our planet. Between 1960 and 1966, the temperature was 106 degrees Fahrenheit, and even in the wintertime, the temperature goes up to 98 degrees Fahrenheit on average. 8 minutes and 20 seconds. That's the time sunlight needs to travel from the sun to our planet. It's still not that much compared to what it takes for the light to reach Pluto, 5.5 hours. Almost 70% of the fresh water we have in this world is held in ice sheets and glaciers. More than 96% of the total amount of water on Earth is in the oceans. The Earth is like some sort of big magnet. Its inner core is actually a sphere made of solid iron, with liquid iron surrounding it. All those variations and changes in density and temperature create some sort of force, which makes the iron produce electrical currents. They are lined up by the planet's spin, and together, they create a magnetic field. There are many stars in the Milky Way, 100 billion, but way more trees on our planet alone, around 3 trillion. You can tell how old the tree you're looking at is by its rings. They can also tell you more about the conditions of a given year, too. When these rings are thin, there was a drought, while the thick ones say it was a rainy period. Earth is a magical planet where even rocks can walk, at least some of them, in Death Valley, California. They leave trails so you can record the path they've passed. Some of those biggest rocks have left tracks behind up to 1,500 feet long. Smooth-bottomed rocks wander around, while those with rough surfaces tend to leave straight tracks. The world that surrounds us consists of atoms, and they seem to be solid. But 99.99% of them are just empty space. An atom is just a really small nucleus and a cloud of electrons surrounding it. These electrons are particles, but they act like waves. They don't exist in one point but are spread over a range of probabilities and occupy lots of space. Take the empty space in our atoms, and all the humans could fit in a really tight space, like the volume of a sugar cube. Australia is slowly shifting north, 2.75 inches per year because of tectonic movements. Australia is one of the top continental tectonic plates that move faster than others. You'd need 400,000 moons to reach the level of brightness the sun has. Sounds a lot at first, but the moon only reflects the light coming from the sun. It doesn't make its own. And even though that's not enough, its brightness depends on the exact angle between the sun, moon, and the Earth. The planet we live on used to have 2 moons, or at least some scientists believe so. They figure the side of the moon that faces the Earth is relatively flat and low, while the other side is way thicker and crustier. The theory says that there used to be the second moon that collided with the thicker side. Some believe there's still a second moon. It could be not a giant space body we see clearly in the sky, but some sort of a small asteroid pulled into the Earth's orbit. Air doesn't mostly consist of oxygen. Almost 78% of it is nitrogen. If you want to see some pretty steep rocks, go to Canada, Auyuituk National Park. It has the biggest vertical drop in Canada. The tallest and the steepest cliff with 105 degrees of overhang and 4,000 feet of rock. A team of 4 American men finally made it to the top in 1985, although there were 30 attempts for that before. It took them 33 days to get up. The Pacific, Atlantic, Indian, and Arctic are the 4 world's oceans. The 5th is confirmed to be the Southern Ocean. It's not defined by the continents around it, but by its Antarctic current that goes from west to east. Research shows this current was created more than 30 million years ago when South America and Antarctica had separated. This allowed water to flow around the bottom of the ocean without any barriers. Melting glaciers and ice sheets means more water in the oceans. It adds the extra weight of all that liquid pressing down the sea bottom, making it sink. The Earth's surface looks solid and kinda permanent, but every 500 million years, it goes through a process of regeneration. Tectonic plates crash into each other. Continental crust creates pressure on the oceanic crust, and that pressure activates the volcanoes. Through time, all this results in regenerating and replacing a majority of the Earth's surface, just like our body regenerates skin cells, replacing old with new ones. Out of all planets in the solar system, Earth is the only one with the outer crust that's broken up into huge surfaces we call tectonic plates. This is an important process that allows the formation of oceanic trenches and mountains, and also helps with protecting the Earth. When microscopic planets that live in the ocean are gone, they fall down to the bottom. The remnants go back into the interior of our planet and get recycled, and eventually end up in the atmosphere, protecting us from overheating and turning into Venus, the hottest planet in our solar system.
Imagine the universe as a gigantic, elastic balloon that's steadily being inflated. That's what dark energy seems to be doing, forcing galaxies further apart. Could this force lead to the end of the universe? Some scientists do think so, and they've named this potential event the Big Rip. It's challenging to study dark energy, even though it's one of the most fascinating aspects of our cosmos. That's because its only visible effect is this gentle stretching of space. On any smaller scale, it's virtually undetectable. Compared to dark energy, studying dark matter feels like a walk in the park. Even though it's just as invisible, dark matter leaves clear evidence of its existence. It latches onto galaxies and galaxy clusters, bending light and altering gravity. Dark energy, on the flip side, just expands. Nonetheless, scientists have found ways to examine it, mostly by observing the universe's expansion. As we peer into the distance, we are, in fact, peering back in time, tracing the universe's evolution. Dark energy could also bring about the end of the universe in a massive, catastrophic event. Imagine watching helplessly as reality itself tears apart with no hope of escape. Frighteningly, it's not some far-fetched scenario. The available data does not eliminate the possibility of a big rip. Is dark energy a force that keeps inflating the universe, or is it more like a separator? If two galaxies are far away from each other, they're driven further apart, leading to increasing cosmic isolation. But anything that's already a strong structure stays intact, immune to this divisive force. Why doesn't it mess things up, you ask? Well, it's because dark energy remains consistent. As space grows bigger, the density of dark energy remains steady. Imagine drawing a circle anywhere in space, taking note of the amount of dark energy there. Do it again after a billion years, and guess what? The amount of dark energy inside your circle won't change, even though space itself has expanded. That is, unless, of course, dark energy has a trick up its sleeve and proves to be more potent than a cosmological constant. All we know for sure is that it's something that drives the universe to expand more rapidly. Or to put it another way, it creates negative pressure. Now, negative pressure might sound odd. Pressure is usually seen as an outward force, right? But in the universe, it behaves differently. Pressure is a type of energy, like mass, that attracts rather than repels. All these calculations are what makes the Big Rip picture a slow, unraveling movie. The first objects affected are the most massive, loosely bound structures, like giant clusters of galaxies. Their gravitational pull will start weakening, causing them to drift away into the growing cosmic voids. Next, we'd notice stars on the outskirts of our galaxy not following their usual paths, but instead drifting away, like party guests saying their goodbyes. The night sky would then start to dim as our Milky Way would gradually evaporate. The disaster would just accelerate from there. The orbits of the planet would begin to shift, spiraling outward. Just months before the end, after we've lost the outer planets, Earth would drift away from the Sun and the Moon from Earth. We would plunge into the darkness alone. The stillness of solitude won't last, however. Any remaining structure would be destroyed because of the expanding space. The Earth's atmosphere would start to thin. Gravitational shifts would cause chaotic tectonic movements. In the final hours, Earth would fall apart. Beyond this point, the destruction would continue unseen. Nuclei, the ultra-dense cores within atoms, would disintegrate next. Black holes' dense cores would get obliterated. In the last instance, space itself would just rip apart. Bad as it may sound, we may never rule out the threat of a big rip. However, it might take so long that all cosmic structures will have decayed before it happens. A rough calculation suggests the earliest big rip could be in about 200 billion years. Technically, the Sun still has about 5 billion years before it fades away naturally. So by the time this event might happen, our solar system would have long been gone. Nonetheless, given the possible implications, scientists are placing a high priority on understanding the Big Rip. Let's be optimistic though. I mean, if we look at the universe's history, we should consider ourselves lucky. We're in what cosmologists refer to as the luminiferous era. It means that right now the universe is still pretty busy producing new stars, and we know how important these celestial bodies are for maintaining life as we know it. However, the golden age of star formation was about 10 billion years ago. Ever since that peak, the rate of creating new stars has been on the decline. Now, why is the universe taking this early retirement? It's not because it's lazy or tired. In fact, it's exactly because we're living in this expanding universe. For a new star to appear, a bunch of matter needs to be squeezed into a relatively small space. It's like trying to stuff all your clothes into a very, very small suitcase. As the universe expands, the matter is getting spread out, leading to less and less room in that suitcase for creating new stars. The Big Freeze, another theory related to the end of the universe, looks at this scenario. Stars will become endangered and then extinct species. This period of star decline is what astronomers like to call the degenerate era. It's estimated to start about 100 trillion years into the future. What'll be left in the night sky at that point? Only the hardened workers of the universe, white dwarfs, neutron stars, and black holes. White dwarfs and neutron stars, the remnants of medium and large stars that have exhausted their nuclear fuel, will eventually cool off and transform into black dwarfs. These black dwarfs are like invisible cosmic spirits, just hanging around without doing much, inert and unseen. Other neutron stars, too heavy for their own good, will stumble under their weight and collapse into black holes. Further into the future, the universe will become a black holes only party. But even these cosmic weirdos can't cheat time forever. Black holes can fade away too. In fact, this idea of fading black holes came from a brilliant mind you might have heard of, Stephen Hawking. He suggested that black holes slowly shed energy in the form of radiation until they shrivel up like raisins and evaporate completely. Eventually, every single black hole will have evaporated. We'll be left with a universe in its twilight years, settling into its final age, aptly named the Dark Era. At this point, both light and matter will be nothing but distant memories. And then, well, nothing. If this Big Freeze theory is correct, the universe will just remain in a quiet, dark state, stretching into an eternity, where nothing else ever happens. Most of these theories seem to rely on the fact that the universe is expanding. But what exactly is it expanding into? We can't help but wonder if there's something else beyond our universe. Right now, this question is one for which physics doesn't quite have an answer for. We don't have enough facts. One suggestion is that time and space came to be with the Big Bang. That happened around 14 billion years ago. so logically there's nothing beyond the universe. However, a huge chunk of the universe is way out of our sight, existing beyond the part we can observe, which is about 90 billion light-years in diameter. Because everything's pretty much the same wherever you look in the universe, we can presume that the bits we can't see would look pretty much like the parts we can. But that's just an assumption. Now, if the universe is infinite, there's nothing beyond it, right? I mean, that's just what infinite means. On the other hand, if it's finite and growing, you'd start to wonder if there's a boundary or an edge, like a universal cliff that separates our universe from whatever is beyond it. It gets even more complicated when you realize the universe has at least 4 dimensions, 3 for space and 1 for time. And it's pretty much impossible for us to picture what that might look like.